Hello everyone. Today we are going to discuss different types of matrices. Before all else, we'll begin with the definition of a matrix. What is a matrix? A matrix is a rectangular array of numbers or functions. And the numbers or functions are called elements or entries of a matrix. This is the general form of a matrix. It consists of rows, which are horizontal, and columns, which are vertical. And each entry or element is denoted using these rows and columns. For example, the first entry, it is in the first row and first column. Therefore, in general, its notation is A11. The second entry is A12. As the name suggests, it is in the first row and the second column, and so on. As you can see, in this general form, there are m rows and n columns. Now, we'll focus on different types of matrices. We'll begin from the small types of matrices and we will go as we go on further, we will see even bigger type of matrices. The first matrix we are going to discuss today is column matrix. As the name suggests, the column matrix only have a column. That is, it has only one column. As you can see in the example, there is one column and n rows. Each of the entries are A1, A2, etc. up to AN. Therefore, it has n rows but only one column. Next is, just like the column matrix, a row matrix. A row matrix only has one row. That is, the matrix is in the form A11, A12, A13, etc. A single row with n number of columns. The next type of matrix is a square matrix. As the name suggests, a matrix is rectangular. And in case of a square matrix, it becomes a square. That is, the number of rows and number of columns become equal. So as it is written, the m by n matrix turns into a n by n matrix, or we simply say it is a square matrix of order n. These are some examples of square matrices. As you can see, the first one is of order 2, the second one is of order 3, and the third one is of order 4. Moving on to bigger matrices, upper triangular matrix. As the name suggests, there are entries in the upper triangular area of the matrix, and in the lower triangular area, it's all 0. That means all entries are 0 in the lower triangle. Now, the triangular region, I'm defining it upper and lower, and it is divided by the diagonal of the matrix. The diagonal consists of the entries that are in the ith row and ith column of the matrix. That is A11, A22, A33, etc., ANN. So, this is the diagonal of this matrix, and these entries are called diagonal entries. So, a square matrix can be divided into two portions, the upper triangle and the lower triangle. And as the name suggests, in upper triangular matrix, there are entries that are non-zero in the upper triangular region, but the entries in the lower triangular region are 0. Similarly, we can define the lower triangular matrix. In the lower triangular matrix, the lower triangular region is non-zero, but the upper triangular region, all entries are 0, as defined here. Next type of matrix is diagonal matrix. In a diagonal matrix, there are entries only in the diagonal of that matrix. That is, the entries will be A11, A22, A33, and ANN till ANN. And the upper triangular and lower triangular region will be 0. So, a diagonal matrix consists of elements which are non-zero only in the diagonal area. In the upper and lower triangular portions, all entries will be 0. Upon defining diagonal matrix, next we will define scalar matrix. Scalar matrices are a kind of diagonal matrix. The only difference or specification is that all the diagonal entries are the same. As in this example, A11, A22 and A33 are the same. In case of diagonal, it is not necessary that all diagonal entries should be same, but in case of a scalar matrix, it should be so. Upon defining a scalar matrix, next matrix is identity matrix, and it is a very important matrix with respect to the type of matrices. That is, these kind of matrices are used in almost all kinds of calculations regarding to matrices, and it is a prominent example in different kinds of matrices that I will discuss later. So we will see what an identity matrix is. As the name suggests, identity matrix means the diagonal elements are 1. That is, this is a scalar matrix. Instead of k, it is 1. That is, k is equal to 1. So we can see here, I have taken 3 orders of matrices. This is the identity matrix of order 1, identity matrix of order 2, and identity matrix of order 3. As you can see, this is a scalar matrix. So the upper triangular and lower triangular region is 0, and scalar since all elements in the diagonal are same, and it is equal to 1, which makes it the identity matrix. So the identity matrix is a scalar matrix. A scalar matrix is a diagonal matrix, and maybe you can say the diagonal matrix. It is a square matrix. Okay. Next type is a zero matrix. As the name suggests, it is a zero matrix. That is, the whole value is just 0. That is, all the entries in the matrix are 0. As you can see, this is a matrix of order 1. It is a zero matrix. Another zero matrix of order 2. And let's look at here. This is a matrix of 2 rows and 3 columns. That is, this is a 2 by 3 matrix. So, unlike the identity matrix, zero matrix need not be a square matrix. Zero matrix can be a normal matrix, a rectangular array. But all the entries should be 0. As you can see, this is an example, and another example I have taken of the order 1 by 2. This matrix is also called a null matrix. Null is a notation for 0 only, and its notation is 0. Next type of matrix we are going to discuss is idempotent matrix. Idempotent matrix is a square matrix. The specialty of these kinds of matrices is that upon multiplying the matrix with itself, we get the same matrix again. That is, a square is equal to a, or m square is equal to m, as seen in this board. I have taken an example. In fact, you can do this as an exercise. You can divide this matrix with itself. By performing matrix multiplication, we get the same matrix again. You can check this using, you can do this as an exercise and check whether this is true. So that is idempotent matrix. The next type of matrix we are going to discuss is nilpotent matrix. Nilpotent matrix is a square matrix which upon multiplying with itself, that is, we take a matrix M, then we take M square, M cube, etc. until we get a zero matrix. If we get such a result, that is, upon multiplying by itself, we get a zero matrix, that matrix is called a nilpotent matrix. The example can be again done as an exercise by you guys. This is the matrix. It is a 4 by 4 or a square matrix of order 4. This is the A square. As you can see, most of the entries have become 0, but here 6, 12 and 6. Non-zero numbers are remaining. Next, we take A cube. That is, we multiply A square by A. Then we get A cube. Again, as you can see, there is a entry which is non-zero. 18, as you can see, is the A14 entry. It is non-zero. So again, it didn't become the zero matrix. But upon doing a raised to 4, which is a square into a square, or even you can do a cube into a. Upon doing that, we'll get the 0 matrix. As you can see, all the entries are 0. So, a square, a cube, and finally a raised to 4 has to be calculated in order to achieve the 0 matrix. Therefore, we can see that this matrix, or matrix A, is a nilpotent matrix. Next type of matrix that I am discussing is involutory matrix. An involutory matrix is again a square matrix, and upon multiplying it by itself, that is squaring the matrix, we'll get the identity matrix, that is a square if I'm taking a square is equal to r. So you can see this is the matrix I have taken. This is a square matrix of order 3. Upon multiplying it with itself, I get the identity matrix of order 3. 1, 0, 0, 0, 1, 0 and 0, 0. Again, you can do this as an exercise. This is a prominent example. It's a 3 by 3 matrix, so it is quite a prominent example, and you can do this as an exercise as well. That's all for today. I hope you had an informative class. Thank you.